everyone. Today we are going to discuss the CSAT micro concept in a number system, the power cycle. Okay, before going into the power cycle concept, first we have to understand why this concept has been frequently asking in CSAT, right? Because CSAT want to waste the time of the aspirants so that he can waste his time by calculating huge numbers in calculation. If power cycle as a concept used in framing such type of long calculation questions, he will waste his own time. He will waste his time. So that was a time bound trap created by the UPSC by using this power cycle. So firstly, we have to understand that CSAT is not all about the calculations, right? Then what is CSAT? CSAT is a recognition of the pattern. So let us dive into the power cycle concept first. So here we have to understand what do you mean by power and power cycle. So let us take 2 as a power, 2 and the power is 1. So 2 to the power of 1 is 2. In the same way, 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8. 2 to the power of 4 is equal to 16. 2 to the power of 5 is equal to 32. 2 to the power of 6 is equal to 64. 2 to the power of 7 is equal to 128. 2 to the power of 8 is equal to 256. So here we are decoding these two words individually, means power and cycle, right? So power cycle is nothing but when this number is repeating after how many digits, after how many cycle it is repeating from starting. So here if you carefully observe 2, so 2, 4, 8, 16, then again 2 came in the units place, so 2, 4, 8, 6. In the same way it will so on continue. So the power cycle of 2 is how many? It is like 2, 4, 8, 6. Again 2, 4, 8, 6. So this repeating pattern is called cycle. That is cyclicity. I hope you got the clarity. So why does this happen? Let us see. Why does this happen? Because we are looking at number mod 10. That means there are only 10 possible digits. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the most possible digits. When you keep multiplying, eventually pattern has to repeat. So whenever you multiply, the pattern has to repeat. There are limited possibilities. So when you multiply repeatedly, the pattern has to repeat and that pattern has some limitations or limited possibilities. So every number raised to power will eventually enter into loop. So whenever the number is raised to power, it will lead to one loop. As we have seen, this is one loop, right? And again it is entering in this loop. So after that it will enter and so on it continues. I hope you are getting the points clearly. So first of all you have to understand that cyclicity is not trick. Okay, it is a property of modular arithmetic. It is a property of modular arithmetic. Okay, but in CSAT, remember this. But in CSAT, you don't need theory. Okay, you don't need theory of modular arithmetic, right? But what you need to recognize the pattern. I hope you are getting the points clearly. So whenever there is a power cycle, you have to recognize. If you recognize the power cycle and how much, after how many digits it is getting into the loop, that is enough to answer the question. Okay. Now let us see which number have which cycle. Okay. Which number have which cycle. Let us examine all possible last digits. So first last digit is 0, right? So always 0 have cycle length of 1. Okay. In the same way, first number 1 always 1 as well as cycle length will be 1 only. In the same way, digit 5 when it is in the units place, the cyclicity will be 1. I hope you are getting my last digit 6. The cyclicity of the 6 will be always 6 and it will be cycle will be only 1. These are fixed numbers. These are fixed with the cyclicity. Which number of which cycle we have understood, right? So 0, 1, 5, 6, these numbers have only one cycle. So after 1, it will again get into the loop. I hope you are getting my point. So before learning the cycle of 2 or 4, you must understand why some number don't have cycle at all. Okay. There are fixed last digit numbers. I hope you are getting my point. So these 0, 1, 5, 6, these fixed last digit number don't have cyclicity, but it will have only one. That is one only. So it is equal to not having a cyclicity. I hope you are getting my point. Okay. Core idea is the cycle means the last digit changes and then repeat. Yes, what do you mean by cycle? It is last digit changes and repeat. That is what we call as cycle. If the last digit never changes, there is no cycle, right? So the last digit is not changing in the case of 0, 1, 5, 6. So there is no cycle for last digit where 0, 1, 5, 6 are present. So there is no cyclicity in this for these numbers. I hope you are getting my point. Remember 0, 1, 5, 6 don't have cycle. So 0 cycle. I hope you are getting my point. Let us see for example 0 to the power of 1 is equal to 0. 0 to the power of 2 is equal to 0. So it is like 0 only. And in the same case 1 to the power of 1 is equal to 1. 2 to the power of 1 to the power of 2 is equal to 1. 1 to the power of 3 is equal to 1. 1 to the power of 4 is equal to 1. I hope you are getting the clarity. In the same way, 5 to the power of 1 is equal to 5. 5 to the power of 2 is equal to 25. 5 to the power of 3 is equal to... So, every time it will repeat itself. 5, 5, 5. I hope you are getting my point. In the same way, if you check with the 6 to the power of 1 is equal to 6. 6 to the power of 2 is equal to 36. 6 cube is equal to 216. So, 6 is repeating. So these numbers don't have cycle. So always understand this 0, 1, 5, 6 number are fixed number that doesn't have any cycle. I hope you are getting my points. Okay. If you understand this 0, 1, 5, 6 number don't have cycle, why? So in CSAT questions, if you observe anything like 1 to the power of n, 5 to the power of n, 6 to the power of n, then any number ending in 0 to the power of n, then the last digit is already decided without any calculation. I hope you are getting my point. Okay. So you have to be very careful which is the unit digit and what is the cyclicity of that number. I hope you are getting my point. You don't need any huge calculations when you observe this type of pattern. I hope you are getting my point. So UPSC always love to frame such type of question to test the certainty based question, option elimination based question. I hope you are getting my point. So be careful while observing the pattern of the power cycle and observing the power cycle questions. Okay. If just simply remember this rule. If last digit is 0, 1, 5 and 6, don't calculate. The answer is fixed. I hope you are getting my point. So the unit digit is always be 1 when it is n to the power 1 to the power of n. And in the same way 5 to the power of n, the answer will be 5. I hope you are getting the things clearly. So we have discussed about the fixed numbers, right? So we will dive into other numbers like 4 digits. Fourth number, 4 to the power of 1 is equal to 4. 4 square is equal to 16. 4 cube is equal to 64. 4 to the power of 4 is equal to 256. Now the number here, the units place is 4, 6, 4, 6. So after 2 digits, it is repeating its loop. It is repeating its number. So cycle is equal to 4 to 6. Then the length of the cycle is 2 numbers. I hope you are getting my point. Okay, this is the first most important concept you have to understand. And if you want to solve the total problem or total sum as a whole, you have to integrate this step 1 and you have to solve with again step 2. Step 2 we will further discuss. I hope you are getting my point. In the same way for number 9, 9 to the power of 1 is equal to 9. 9 square is equal to 81. 9 cube is equal to 729. Okay. Again, the cyclicity is repeating from 9 to 81. So, it is like the length of the cycle is 2. So, you have to remember for 4 as well as 9, the length of the cycle is 2. I hope you are getting my point. And when you see last digit as 3 and it has power 2 and it has power, then what you have to check? So 2, 4, 6, 8. 2 to the power of 1, 2 square, 8 and 6. 6 16. I hope you are getting my point. So what is the length? 4 numbers. So length of the cycle is 4. I hope you are getting my point. So in the same way, the last digit 3, then you need to check 3 to the power of 1, 3 square 9, 3 cube 27, 3 to the power of. So the cyclicity will end here itself. Why? Again 3 is coming and it will be in the loop. So the cyclicity of the last digit 3 will be 4. So if you carefully observe, for 0, 1, 5, 6, the cyclicity is 0. The length of the cyclicity is 1. Okay. And if it is, the length of the cyclicity is 1, that means the cycle is 0. I hope you are getting my point. The same way, for 4 and 9, we have seen 2 is the cycle length. And now we have seen 2 and 3, it is 4. I hope you are getting my point. 1, 2, 3, 4, 5, 6. We didn't get 7 as well as 8. Let's check with 7 as well. Okay. If you find 7 in a unit digit and it has a power, then what will be the cycle length? 7. 7 to the power of 1 is equal to 7. 7 to the power of 2 is equal to 49. So 7 cube is equal to 343. In the same way, 7 to the power of 4 is equal to 2401. So again, if you add or multiply 7 here, the cycle will repeat. I hope you are getting my point. So the length of the unit last digit 7 will be like 4. The length of the cycle will be 4. I hope you are getting my point. In the same way, the last digit 8 will be like this. 8 to the power of 1 is equal to 8. 8 square is equal to 64. So 8 cube is equal to 512, and 8 to the power of 4 is equal to 4096. So again, if you multiply 6 into 8, 48. So the number is repeating and it will enter into the loop. So we have to calculate 1, 2, 3, 4. So the length will be like 4. I hope you are getting my point. Now let us summarize what we have discussed till now. It is that some numbers are fixed. Those numbers are 0, 1, 5, 6. Right? Cycle length will be 1. Okay. So there is no 0 cyclicity. And when it comes to 7, not 7, 4 and 9, the cycle length will be 2. I hope you are getting my point. For numbers such as 2, 3, 7 as well as 8, the length of the cycle will be 4. Okay. Up to this you have understood clearly, right? That's the entire system, right? This is the entire system. Right? So whenever you see such type of systems, you should not panic in the real-time exam like situation. But what you have to do is you have to recognize the pattern. So let's see what you gives in real time. What you gives. Okay. It will give numbers like 7 to the power of 103. Okay. The size of the exponent doesn't matter. Only the position inside the cycle matters. Okay. In unit place, what is the number? 7. As you know, the 7 length of the cycle is 4. Okay. Now what you have to do? The cycle length is 4. Then take exponent mod 4. Okay. Cycle length is equal to 4. So now you have to divide the power by 4. I hope you are getting my point. When you divide the power by 4, let's divide 4. 4 to the 8. So 2 remaining 2 here. 3. 4 5 the 20. So the remainder will be 3. I hope you are getting my point. The remainder is 3. Okay. So take the third element of the cycle of 7. So the third element of the cycle in the 7 is 7 ones are 7, 49. Then again 49 into 7, 9 7 the 63. So 3 will be in the digits, last digit. So the answer will be 3. Answer done, right? The last digit will be 3. If the question asking about the last digit or unit digits. I hope you are getting my point. I hope you are getting the things clearly. Okay. Now let us jump into the PYQs. Okay. Question was, what is the unit digit of 7 to the power of 103? As we have solved that one, right? So the first step is you have to look what is the unit place. Here the unit place is 7. So you have to know what is the exact number of length of the cycle of 7. It is exactly 4. Now what you need to do, you have to take the power and you have to divide that power with the length of the cycle, right? So 103 is equal to 25 and remainder will be 3. I hope you are getting my point, right? The same way in CSAT 2014, which of the following has unit digit 1? He asked which of the following have unit digit 1. He has given options like 3 to the power of 50th term, 7 to the power of 75, 2 to the power of 120, 9 to the power of 11. I hope you are getting my point. You don't compute. You don't start immediately calculating. you reduce each to the cycle position. Okay, here 3 to the power of 50 is 50 mod 4 is equal to 2. I hope you are getting my point. Okay, you have taken 50 divided by 4, that is equal to 2. The second element in the cycle of 3 is 9. So 9 is the unit place. So here 1 is the unit place. So we can eliminate this one. So this is like elimination approach. Whenever you see 1, then that is the correct answer. I hope you are getting my point. So let us see all the options. Okay, 7 to the power of 75 is equal to 75 mod 4. That means 75 divided by 4. I hope you are getting my point. Right? 7. So 75 divided by 4 means it is like 72. The remainder will be 3. So the third element in cycle of 4 of 7. So what is that element? 7, 49, 9 into 7, 63. So 3 is the unit digit. So from this process we can eliminate this one also. So this is not the answer. This one eliminated, this one eliminated. Right? 2 to the power of 101 plus 3 to the power of 102 plus 5 to the power of 99. Okay. Find unit digits. This came in 2016. Okay. Find unit digit. You reduce each separately, right? You can reduce this 2 to the power of 101. So the power cycle is 4. And that number has to be divided by 101 the power by 4. Okay. If you divide, the 1 will be remainder. Okay. Now that 1 will be the element of the power cycle. First element is 2, 4, 6, 8. Again 2 will occur. So 2, 4, 8, 6. Right? So the first element is 2. I hope you are getting my point. In the same way, you have to find out 3 to the power of 102. Then the length of the cycle is 4. 102 by 4. You can get a reminder here 2. The second element of the cycle will be like 3, 9. So 9 will be the 2 plus 9. Right? In the same way, 5, 9. So the cyclicity of the 5 will be always 5. Right? So it is like 5. Okay. So 9 plus 2, 11 plus 16. I hope you are getting my point. So the unit digits will be 6. This much simple it is. I hope you got clarity. In the same way, if you observe 2018 question, find the remainder when 3 to the power of 201 is divided by 10. So here the divisor is 10. Okay. Means only last digit matters. So only last digit matters because we are dividing by 10. So we can use this formula. I mean to say the power cycle concept here. So 3 to the power of 101. The length of the power cycle of 3 is 4. So 201. So if you divide, so 450 is a 200, right? So 1 will be the remainder. So the length of the cycle of 3 is 4. 3. So 3 will be the last digit. So the first element is 3 and the remainder will be 3. I hope you are getting my point. In the same way, 2019 and 2020 pattern certainty, UPSC asks which of the following must end with digit 6. Which of the following end with digit 6? The option is like 2 to the power of n, 4 to the power of n, 8 to the power of n, 6 to the power of n. So this is very certain question. If you know the concept clearly, you can directly come to the answer within a second. Because you know that 0, 1, 5, 6 don't have cycle. So it will have only one element. That element is the number itself only. So this is the answer. I hope you are getting my point. This pattern is inevitable in any questions. If you want to make a trap in a longer calculation, it will use power cycle as a tool. So, if you understand that 0, 1, 5, 6 have no cycle and the first element will be the number itself, then you can solve this such type of question. In the same way, if you know 4 and 9 have only 2 cycle, I mean the length of the cycle will be 2. Okay. And in the same way, 2, 3, 7, 8 have a length of the cycle will be 4. I hope you are getting my point. If you understand this concept carefully and if you understand how to use the concept of the length of the cycle and you are going to divide with the power, when you are dividing power with the length of the cycle, you will get a remainder and that remainder has to be taken from the element. First element, second element, third element. If the remainder is third one, 3, then you have to take the third element of this power cycle. Okay, the length of the cycle. That will fetch you the answer. I hope you are getting my point. So, what UPSC is actually testing is, they are testing can you ignore intimidation? If you ignore intimidation, I mean to say not committing to the calculation. Can you reduce exponent using modular thinking? If you reduce the exponent with modular thinking, you are reducing the time in solving the question. I hope you are getting my point. And it is testing whether you can eliminate option without solving fully. This is what the UPSC is expecting from you. Okay. Student loses marks here. First and foremost thing, student loses marks because they respect large exponents. Whenever they see large exponents, they will get into the panic mode and they start calculating. Thinking solving fully is safer. Okay. And in the same way, they don't trust reduction. So if you want to reduce the exponent, you have to have a very good practice. Practice means you have to practice UPSC style question. If you practice UPSC style questions, you will get a clarity about the upcoming questions also, as well as you can reverse engineer with the PYQs itself also. I hope you are getting my point. So finally, I can say one thing is when you see large exponents, unit digit, remainder by 10, expressive of power, your brain must say cycle. Okay, only cycle. If that reaction is automatic, you will never waste time on power questions. So the major important, after listening this class, you may get that thing that I have understood the power cycle. I can solve easily CSAT questions whenever the question comes on the power cycle. But the halfway problem has been done. But it requires practice. Practice and practice. And not a vague questions to be practiced. You have to practice the same way how UPSC is going to frame. Okay. If you want such types of practice questions, please comment cycle in the comment box and I will share you with the PDF of the practice questions. If you like this information on the CSAT micro concept, please like, subscribe for more such videos. Thank you.